As Rick said, my name is Jerry David Chan, and I live in Japan, and although I'm Canadian. And kind of opposite from Pavel, I started off in Wall Street, and now I'm a consultant, whereas he started as a consultant, and now he's doing financial services. So it's kind of like a reversal there. So having worked in Wall Street, in Goldman Sachs, JP Morgan, small banks, on a trading desk, I got an appreciation for the market and how finance works. And that's why when Bitcoin came around and I caught wind of it sometime in 2013, I was very, very interested, and for about a year I watched it, and then eventually I just couldn't sit by the sidelines and just watch this new revolution happen. So I decided to leave Wall Street, a very well-paying job, and start doing, working on blockchain projects. So that's a little bit about me, and I guess that's why they asked me to speak to you here, to tell you a little bit about what I guess the blockchain, the industry is doing in Japan and et cetera. So I started making a presentation actually, and I thought about, I started creating this standard bullet point slide, and I thought, you guys don't really want to listen to another presentation with equations and bullet points and stuff. So instead, I'm just gonna talk and give you a little bit of my experiences. So that was about the only slide I had done before I gave up on this whole presentation. So, so in the industry, there's a term that we use. It's called that kind of describes what happens whenever a new disruptive technology comes in emergence. It's called FUD, or FUD, as we call it, and it stands for fear, uncertainty, and doubt. And I hope that by the end of this talk, I will basically have eliminated at least two of these mental obstacles for you. Hopefully the fear and the uncertainty. You might still have doubt, but that's okay. I still do. So let's talk a little bit about history. Why is blockchain such a revolution? I kind of see this as similar to the change in the computing industry, the move from mainframes to client server, right? Everything, all the data was in one machine, a very expensive machine owned by a very rich company or the government. And then we moved to a model in the 80s or in the 90s to machines which were light clients, and then bigger, maybe more powerful machines which would act as servers. And that was a revolution in itself. And kind of blockchains is sort of the next evolution. Now blockchains, if you think about it, is kind of like a distributed or decentralized mainframe, right? There is one ledger. There is one instance of truth. There's one decentralized computer. So that's actually quite revolutionary. And all this started just from a simple paper from a group of people or a person or maybe, who knows, called Satoshi Nakamoto. He posted a white paper on a cryptocurrency forum in 2008. And that described a system that he proposed of creating a digital decentralized ledger, which was supported by and validated by the members, by anybody who would join the network. And it used a system called proof of work and its own native token to reward the validators on this network. And this network is called Bitcoin. And it has been greatly successful, and 7 years later, it's still working, and it has zero downtime, and it's processing now over 200,000 transactions a day, and over 150 million US dollars every day, 24 hours a day, 365 days a year, and for 7 years. So why am I talking about Bitcoin, right? This is a blockchain talk. Well, I think it's very important because while I believe blockchains it is the revolution here, we do need to understand where we came from in order to understand what to do with this new technology. And where we came from is the technology that came from Bitcoin is basically currently the most secure blockchain. But I'm going to talk to you about the differences between a public blockchain like Bitcoin and private ones, like private blockchains, of which there are many. So let's first talk about what are the problems that Bitcoin solved. Right? What can you do with a decentralized ledger? Well, you can do many things. I mean, you could do value point systems, you can do loyalty points, frequent flyer miles, you can do audit records or ownership transfers, I think, as Pavel mentioned in his slide. You can do decentralized derivative exchanges, peer-to-peer lending. All these sort of financial services is based around a ledger, really. And if you can make this ledger decentralized, well, then you can have anybody join. So what is it that, why isn't it that the case where we've been doing this up to this point? Why couldn't we do this up to this point? Well, it boils down to something that a certain number of qualities which Bitcoin has. And these special qualities of Bitcoin is what kind of makes it, what was the revolution in Bitcoin. So let's quickly go through these 4 features of Bitcoin. The first one is that it is programmable. So it's kind of, you've heard the term programmable money. So Bitcoin is just, or blockchain, in fact, is just a layer upon which you can build your own applications, like ownership title transfers, like online gambling sites, like yes, yada, yada, yada. So that's the first feature. The second feature is that it is immutable. So what that means is that there is a certain guarantee, a certain level of guarantee, that the data on the blockchain is authentic and is consistent, right? And you don't need a intermediary to give you this guarantee. The guarantee is implicit in the technology itself. So that's the second feature. The third feature is that it is open, right? What does that mean? It means that all the transactions within the ledger are transparent and completely traceable. There's everything is public, or within the group of people using the blockchain. And fourthly, the last one is that it's permissionless, which means people and members, actors within the blockchain can join and leave as they please without asking for permission. And the system will still be resistant against malicious actors, attacks, without a third party being the administrator, being the security administrator. So those are the 4 qualities of Bitcoin. So these 4 qualities is what makes Bitcoin a trust minimalized system. Trust minimalized, because it's not really possible to completely trust-free. You have to trust somebody, but you just want to minimize the amount of trust you have to put in any one group. So this thing happened. Oh gosh. There you go. So what about private blockchains or consortium-based blockchains, like the ones R3 is creating, like many of the ones you've heard today? What about them? So what they try to do is they try to replicate the benefits of Bitcoin while sacrificing a little bit of the features in order to gain more control for the administrator of the blockchain. And that's fair. If you think about it, the features of Bitcoin give it its trust minimalized condition. But if trust isn't that much of an issue for you, then you're maybe willing to sacrifice some of those features. So for instance, do you trust your money in the bank? I do. I live in Japan, and I trust the money in my bank. I trust that the money is going to be there tomorrow if I deposit it today. I trust that I can pay using Furikomi or interbank transfers. So there's already a trust relationship between me and my bank. And so if I trust the bank, then of course I don't mind if the bank were to use a private blockchain to facilitate the internal transfers of money between them. So that's a good example of If you trust the operators of the private blockchain, then it's not a problem, and you can sacrifice a couple of the things, of features of Bitcoin. What are the certain features that banks may not necessarily like of Bitcoin? One of them is immutability. It's really great to have immutable records, but sometimes actually you may need to change them for good reason. One example of this is, for instance, if you were to track ownership transfers and somebody just honestly made a mistake. I accidentally incorrectly entered my name, a wrong name into my mortgage title or something like that. And there's an honest reason why that record needs to be changed. And so therefore, sometimes immutability is a liability. Another case is, for very good reason, banks would want to control the people who can use their system. So in this case, the feature they are willing to sacrifice is the permissionless aspect, because they obviously need to do KYC, AML, which is anti-money laundering, and know your client measures in order to abide by the local regulations of the country. So that's another feature that they're willing to sacrifice, and that's fine. So what are private blockchains good for? So let's talk about the use cases of private blockchains or consortium blockchains. Well, if you try to think about what they're good for, pretty much anything that you can imagine a shared multi-user database would be good for, right? And so basically, you gain the better uptime, right? Presumably, the larger, the more distributed your blockchain is, the more uptime you have. Like Bitcoin is 24/7 for 7 years. Maybe a private blockchain would something close to that, depending on how many members in the consortium blockchain. Another thing you can gain is you can reduce your operational risk. So what do I mean by operational risk? I have a good story about this. Operational risk, let me just jump into the story. In Japan, we have something, most companies are still on something that I call the fax standard. So what that means is that a trade is only confirmed, or any sort of instruction is confirmed after the fax is sent and read. So there was a case, actually, I heard from a friend of mine at Swift, that a client wanting to change the settlement instruction on a trade, which was going to settle in physical, so I assume it was maybe coffee beans or pork hogs or cows, I don't know, maybe gold. And the client sent the settlement change instruction through Swift to the broker. The broker, through Swift's network, confirmed, yes, we acknowledge that you wish to change the settlement instruction on that trade. And then, as part of the process, the client sent the fax confirmation to the broker. Now, I don't know about you, but you've seen, if you've worked in an office, your fax machine / printer is some machine about this big, and everybody prints everything out of it. And every time you walk to the printer, there's a stack of papers on top, and sometimes you just take the stack out, you put it on top because it's not yours, and you leave it on top, and hopefully somebody's gonna get it. So what happened, unfortunately, as fate would have it this day, the broker somehow lost that fax. It fell maybe behind the printer or something. And as a result of that, the trade settled in physical. And as you can imagine, client was not very happy. And because it was technically the broker's fault, they agreed to cover in the market for the physical delivery. That trade lost the broker $1 million US. $1 million US because one piece of paper fell behind a fax machine. So you can imagine now, if they used one ledger to represent the settlements for this particular exchange, this futures exchange, maybe this kind of thing could have been avoided. Some other examples where private blockchains, or blockchains in general, could be useful. Hong Kong is a city of 7 million people. If I were to ask you, what is the largest depository institution in Hong Kong? Who would you say it was? What is the company in Hong Kong that has the most accounts, depository accounts? Bingo. This guy's from Hong Kong. So most people say HSBC, Standard Charter, all wrong. The MTR, the public transit system, or the Octopus card, is the largest depository institution, private I think actually, I may be wrong, but I think it's privately owned, that in the entire city, because it has literally 7 million accounts. Everybody in Hong Kong has an Octopus card. Everybody takes the train. Everybody uses it for most day-to-day purchases at a convenience store. So this is another application where blockchain can help them reduce costs. We know it's applicable because they're running a system like this. And imagine connecting the ability to transfer your Octopus card balance and using it to pay with other institutions wouldn't require some sort of back-end server retrofit attaching to their network. What if it was all some sort of private, maybe public, semi-private, public blockchain? So that's another example. Another one, maybe for the guy who is smart enough to get the Octopus card. In America, there's a company that has 1.2 billion on accounts, $1.2 billion of accounts. They handle 41% of all trades during a day, in the morning specifically, in a day. Anybody guess what company this is? That man over there knows. That man with the pink tie, the one typing into his red computer. Yeah, you know. Who do you think, which company is this? You know because you just drank out of their product. They make coffee. Starbucks. Starbucks point cards have 1.2 million. That's more than some banks in America. And they are using their own private blockchain, although they're not using a blockchain yet, but imagine how the amount of money they could save if they somehow retrofitted their system to use a blockchain. And then how many other people would be able to take Starbucks points to buy other stuff other than coffee? So that's another example. Here's one. In Japan, we still use a very archaic system called hanko for identity, for stamps, personal stamps. I don't know if they use it in Vietnam here. I think they still do use it in China quite a bit and in Korea. But the problem with hanko, which is like your personal identification stamp, for all signing of all contracts, you need your hanko. And a hanko is a physical lump of plastic, buffalo horn, metal, something that you make, or you have somebody make for you, obviously, and you keep, and whenever you need to sign a very important contract, like a mortgage, or you get married or something like that, you have to bring your hanko and you have to stamp in triplicate, maybe even like quadruplicate, everywhere on the contract. Now, this system works great for the last 2,000 years, but the problem with this identity system, which I must admit is still better than signing, with a hand, because it's really hard to do handwriting analysis, and I've had my problems with handwritten signatures. But the problem with the hanko system is that there have been cases where someone has stole somebody's hanko, and then sign contracts on their behalf. I think the case I remember was somebody actually got themselves married or divorced, one of the other. Someone would just, your wife or your husband, as the case may be, would find out where your personal hanko is and run to the ward office and get themselves divorced from you. And you couldn't do anything about it because you've signed it. There's no legal recourse. You've signed it with your hanko, it's done. So a system like that obviously depends on private keys. And what if we could use private cryptography on a blockchain in order to track identity and to sign contracts? That would be great because, without getting too technical, private keys allow you to create a signature that proves you own the private key, but except you never need to take it out of a safe. You never need to remove a physical thing out of a box. There's nothing for anybody to steal from you because the private key is a digital signature, maybe a set of 12 words that you memorize in your head. Nobody can steal that from you. Well, almost, It's really hard to take the 12 words from somebody. So that's another example. And another one I want to lead into is taxes. Everybody loves taxes. Everybody loves paying taxes. Imagine if, in order to transfer ownership of a vehicle, because in Japan, when you need to sell something to somebody, your car, for instance, you need to pay a stamp tax. There's probably another licensing tax, like a shaken tax or something. And imagine all these taxes, which is very, very troublesome for somebody to go to the government office, line up, literally buy a stamp, right? A stamp which is maybe whatever the amount of tax would be, and so that you can stick it onto the form so that you can submit it to the bureaucrat. Imagine if you could do all this online, digitally. With blockchains, and blockchains and tokens which represented the car, you could provably show that you've paid the tax. For instance, by buying this stamp tax token and destroying it, like provably mathematically destroying it, which shows that you've paid it, right? You bought it and now you destroyed it, it's gone. And therefore, only then would the blockchain allow you to transfer the ownership token of your car to somebody else. And all this would be done automatically by software, as opposed to having somebody in a window and somebody making stamps and sticking stamps. So this all is great. This is awesome. There's a lot of stuff we can do, but what are the risks? So let's think about the risks of blockchains. One of the reasons why we have the current system, which is called double accounting, double book accounting, which is that every bank and every institution keeps a record of what it owes with somebody else, and every bank does this. So as long as I have an outstanding balance, positive or negative, credit or debit, with another institution, I keep track of that. And the reason why this system has worked so far, and it's pretty good actually, is that if anybody makes a mistake in accounting, the other person is going to know, right? So any mistake anywhere is reconciled at the end of the day, as long as every institution checks its books, and if there's a discrepancy, you call the other person and say, hey, I think you got something wrong. And they're like, oh, okay, yeah, I think so. Or, oh, you got something wrong, right? So if the one thing that we must be wary of before we try to blockchain everything is that if we move things onto a blockchain, especially one that's private, you do have the risk that once that blockchain has been compromised, then since that is the only one record, then it's going to be very hard to find out what really happened, or what is the true version of truth. This is the case for private blockchains. So you have a systematic risk, right? There's an increased systematic risk. Now the other type of risk which you incur is what I call a wealth aggregation risk. If everybody were to then, for instance, a good example of this is you hear a lot of blockchain talk about putting assets onto a blockchain. Imagine you were to use a blockchain to move assets worth millions of dollars each, tens of millions of dollars, let's say. So if the blockchain was the representation to move hundreds of millions of dollars, then it's a very, very large incentive for hackers to break into that, to steal those assets, right? So pooling value into a blockchain means an increased target for hackers. And we know blockchains are only as secure as the physical security of your private keys. And we remember, I don't know if you heard of the recent case where a bank basically had over, I think, 7 billion, or they attempted to steal 7 billion. They managed to steal only 150 million money from it was either was it Philippines? I'm probably wrong here. It was through Bangladesh. Somebody accessed the bank manager's SWIFT terminal. And once you have access to a bank's SWIFT terminal, you have access to the bank's accounts. So that's the sort of risks blockchains are not going to help you with. Because in the same way, if you lose access to your private keys, then a perpetrator could do whatever they wanted on your behalf. So there is the increased risk of value pooling. So in kind of summarizing everything that I just talked about, we're talking about a disruptive technology here. And disruptive technologies require people who can think out of the box to sort of realize the potential of what it can become. The best example of this I can give you is, any of you remember when they first invented touchscreen technology interfaces? Maybe I'm older than I look, so I remember when they invented this stuff. It was like late 90s. I mean, Apple invented it probably in the 80s, but they never really got popularized until the late 90s. And if you remember when they first came out with the interfaces and the operating systems to use touchscreen, what did they look like? You remember? They looked like you took a pen, a stylus, and you tapped on the screen, on a little keyboard on the screen. And the keys were tiny. They were like half a centimeter. And it was like Windows CE, I think I was doing this on. And it was insane. But I still loved it. It was so cool. I mean, I was typing into a little phone. But it was very clunky. And you can understand why people would design this interface, because people are used to using a pen, and people are used to the layout of a keyboard. So people just did this because it seemed natural. But of course, that was horribly inefficient. And the next iteration, I don't know if you remember this, but Palm Pilot. Did anyone have a Palm Pilot? Palm Pilots came up with a brilliant script. They came up with a new way of writing letters so that you wouldn't have to write the letter E like exactly like E. And of course, I'm speaking about English, so I apologize, but I'm sure Palm Pilot had other languages where you could just write the E in somewhat a natural way. It's kind of natural. You could almost guess how to write the letter T and the letter small h and the big H, and it was really cool. But it was still writing one letter at a time. It was nicer than tapping on a keyboard, but it was one letter at a time. And then as software got more advanced and computational power became more powerful and in small dimensions in your phone, then software became able to predict kind of what you're typing, even when you're typing with this fat, inconvenient implement on the end of our hand, right? You can thumb type, and you can mash all over the keyboard on your iPhone, and it would still kind of guess what you're typing, and it would guess the right letter. That was pretty cool. So, and that change was because of software changing on the back end. And now, does anybody use a Google phone today? Android? Right. 16 years ago, would you have been able to even fathom that you could type, as I typed this speech, by scribbling on your screen, right? Google, Android, the typing interface is you literally just take your finger and mash it all over the keys as if you're kind of just looking at it, kind of blindly, just like, and 98% of the time it gets the right word, at least in English. So we're talking about light years of technology that was started from the simple invention of a touch-sensitive screen. So blockchains is kind of like that. We're at the point where we've just invented the technology. Now we're waiting for the people who can think of all the interesting things we can do with it. Bitcoin was only invented 7 years ago, and look at where we are now. I want to see where the next 7 years is going to take us. So in closing, I hope that we don't fear itself so much. Fear is natural when a new thing happens. Fear is our animal brain telling us that there is a potential danger or risk, or maybe the environment has changed. And therefore, we should be alert, right? And that's good. That's an evolutionary response. And evolution is all about changing to adapt to your environment or to a new environment. And if we cease to evolve, if we cease to change or to embrace change, then we risk being left on the sidelines as evolution passes us by, the industry passes us by, and we are left as a footnote in history. So we can profit from this if we see the potentials and get on board with this change. So I hope with this you feel a little bit more informed, probably a little bit inspired, hopefully, but probably still a little doubtful. But as I told you in the beginning of the speech, I could only help you with 2 of the mental obstacles of fear, uncertainty, and doubt. The last one, I'll have to leave up to you. Thank you.